Welcome, 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 welcome. I'm Blades, and let's explore. Here we go. We are back with our files. So I want sources from the last episode. Did anybody spot the mistake I made? Did you? Huh? I don't know. Yep, I made a mistake. Z-axis on OpenGL. It's minus going into the screen, plus coming out of the screen. And what did I set my verts to? Plus. Can we have a minus, please, Blades? We're looking into the minus. We don't have a camera. Well, we do. We have an automatic default camera, which OpenGL gives. It's at the origin, and it looks into the screen, which is minus. So at -1, and stop setting that to identity. I wonder what we get. We get something that's probably not quite right. Well, I'm hoping so anyway. Yeah, we're getting something that's not quite right. But it's at least more of a square than it was. If we go back into exploration and we shift our angle of view here, let's bump it up 10 degrees to 65 and see if we can get any better on this. I don't know. Will it do any better? Probably not. But it's good enough. Good enough to cook eggs with. Yeah, that's better. So, we have our square, and we have an angle up and down of 65 degrees. Yeah, that works alright. Our aspect ratio's working a lot better. Yeah, whoa, it disappeared on me. Come back. So, there we are. That's not right. That's very not right. Who asked for a purple vertex, a green vertex, and a blue vertex, and a red vertex? Was that me? Nah, I didn't ask for that, did I? I'm sure I wanted RGB and white. I'm sure those are the colours I put in. What's going on? Yeah. What is going on? So our colours are wrong. Let's get back to test 2. It's interesting. It's interesting to get things wrong. I've got a feeling it's because we have 4 numbers for the colours and 3 numbers for the verts, and yet we're asking for 3 and 3. Well, let's see what happens if we change that to a 4. Dunno. Let's try it. Ba 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 boom boom. Bing. There we go. RGB white. Simple, really. That number is the number of numbers. Number of numbers, yes. Number of floats in one part of the vertex. So our vertex is now made up of 3 floats for the position and 4 floats for the colour. And that's what it should look like. There you go. And it keeps its, well, squarishness. Does it go right down? Yeah, it does. It goes right down. You're doing the thing. Whoa, that's cool. No, that works. Whoa, yikes. Can you tell I'm recording this? Yeah, you can see the flicker. There we go. So we've sorted out our perspective, which really has annoyed me, because today's is about MVP, which is model view projection. I call projection perspective. Yes, I do, because that's what it is to me. True name for it is projection. So really that should say projection, and that should say projection. Yeah. I'm going to change it because that's the correct thing. If I call it perspective, don't blame me. So projection, don't call me out on it because I don't care. Right, copy. Let's have that in there. Paste. The first things that really I should do here is still do this line, because it's good practice. So I'm going to cut that out of there. We can get rid of this line now. We don't need it. But at the top, I'm still going to do, for good practice, that. It's not going to affect anything, don't worry. But I'm also going to do 2 more black boxes of jiggly numbers. I will want a view and a model. So let's just put in AQ matrix black box 4x4. That's 4 numbers jiggling around by 4 numbers, or 16 numbers. And all I'm going to do here is put in a view. So we'll have a view. Okay. Can I? Yeah. Right. Can I do this? No, I can't. So view, semicolon, and what else can we have? I'm not liking this already. Do apologise. Model. And because we haven't got them, cut those out of there. Let's put it at the top. Always define your variables at the top. So yeah, I'm going to put our view set to identity. That's the magical black box that does nothing. Yeah, identity is called. Model. I'm just going to keep calling it the black box of jiggly numbers because to most people it is. To me it isn't. It's a matrix of 4x4 numbers, and the identity matrix is nearly all zeros, but it's got 1 point zeros in the diagonal. Reason for that is because it uses homogeneous coordinate systems, which is now gone straight over your head and into the black box of jiggly magic numbers. Okay. So now we can put in here them 2 times view and times projection. Yeah, model. There we go. I hope I've got them in the right order, but if you ever go through this and you find out that I'll put them in the wrong order, don't worry about it. It's just me, I'm an idiot. Okay, there's my disclaimer. Where would we get the view from? So let me just explain from here. View, I'll have to put it as a comment because we haven't got it, equals camera, probably a pointer for a camera, and we will put in get camera probably call it matrix so that it's not, or get camera view or something like that. Yeah, we'll call it that, camera view. There we go. That makes more sense. That don't put that on, it's a comment. That's what we would do to get the view. Where would we get the model from? We'll probably do something like model equals our entity, because that's probably what we'll call it at the end of the day. No, it'd be our object, wouldn't it? Well, entity I normally call it. Okay, because I use an entity system if I can. Entity, and we would get it would be model matrix in this case. Model matrix. We'd do something like that. We'd have a class called camera. We would have a class called entity, some kind of entity. So it would be object. Yeah, object entity. Yeah, that's better. That makes more. I'll call it our object. There we go. Does that makes more sense in English? But that's the kind of thing that you'd be looking to write in C++. Can we do anything with the model? I don't know. Let's take a look. Because that would hold our location, rotation, scale, things like that. Let's have a look, see if it's got anything helpful in here. Still on shader program. God. Give me a break. There we go. Let's have a look at this here. We can look at things. That's great. Oh, we can rotate it. Yeah. You do them in order. You locate, rotate, and scale in the correct order. You usually do them in reverse. Angle. That means degrees, I think, in Qt. I hope it does. X, Y, Z equals 0. Yeah, that's okay. So it's angle and axis. So if I rotate it, let's try it. Let's just test that line out. So if I take our model, and I'll put it here as an example, I suppose. That doesn't work. That works. So let's put in our model and rotate. We'll give it an angle of 45 degrees, because that's an easy one to test to see whether it is in degrees. And we want it around the z-axis. So that is, oh, it says it wants a const q vector 3D. Yeah, right. Whatever. That's x, y. Z-axis is into and out of the screen. So we'll just do that. Is that legal? Yes. Thank you. 45 degrees around the z-axis. I don't know. There you go. It's 45 degrees around the z-axis. It's moved. Which is interesting, because if I make that a count of some kind, let's say we'll call it m_deg for degrees. No, I'll put it in. Why abbreviate? Because I can't spell degrees, that's why. We give ourselves a variable to play with. How about that? So I'm going to copy that. Let's go to the header file. Give ourselves a float to play with. Just put the m_degrees in there. That's that done. Let's set it to 0 at least. Let's give it a starting value. I'll pop that in there. 0 will do. Well, it's 0.0f. There we go. Don't forget the f's. otherwise you're getting doubles and not floats, and floats, sorry, doubles are double the size of a float, and you're just wasting memory at this stage. So we now have m degrees, and it's 0 at the moment. But what happens if, after every time we do that, we put m underscore degrees plus equals 0.001f. Yeah. That works, doesn't it? No. That works, doesn't it? Yeah. There we go. Come on, let's run our test. Yep. That's exactly what I expected. Let's knock a 0 off, shall we? And run again. And this is why it's called testing. That looks okay. But we can relocate it as well, can't we? So you can see it's turning nice and slowly, but it's turning. That's called animation, that is. Look at the smoothness of my animation at 60 frames per second. My animation. Oh, love it, I'm making words up. Yep, that's called computer animation, that. Yeah, go figure it out yourselves. Muppet Me is afloat. I'm really having fun. Let's put that to there. Let's get this thing moving. I don't want it to move too fast, that's the thing. That's smooth. Yeah, that's fine. That's smooth. It's got a windmill effect. Now what I'm going to do is try and get this in the wrong order. So can we do a relocate? So position, scale, rotate, perspective. Yeah, we've already done the perspective one. Transform, that's called relocating to me. Oh, it's a Q transform, is it? To transform. Translate, here we go. X, Y, Z. Right, let's try it. Lovely. They call it translation, relocation, I would say. But what I'm going to do here is I'm going to do a model. No, I'm not. I'm going to do a model dot translate to affine. Well, let's have a look at what we've got here. To generic matrix. Oh, right, okay. Yeah, translate. And for translation, we're going to put in nothing for the X. Nothing for the Y. And everything in the minus Z. So that will be minus M underscore degrees. There we go. That'll do it. Now, of course, we're not going to see it because until that reaches 0.1. Oh, we will see it. Oh, that's fine then. Probably won't see it to start off with though. Let's just, yep, there it goes. Whoa, that was way too much. Bye. It'll get to 100 and disappear. That's a long, long way for 100 meters. Yep, there it disappeared. Wow, that's how far we can see. Yeah, you see, you can do that. But what happens if I put that? I think this might just reverse them anyway. Oh no, cut. What happens if I put it above? This is interesting now. I want to be able to see it as well, please. So we can do that there. It's just so it gets to 0.1 so we can see it. Now what happens? It does exactly the same thing. Oh, that's unfortunate. Oh well. But there you go, you got motion. That's how easy it is to control. So that's exactly how easy it is to control your camera as well, which means we could use something like WASD for forwards, backwards, strafe, left and right, and we could use our mouse with right click to look around. So that would be a very simple camera to make. The model matrix would make a model which would include all of our initialization here. So all of that will get moved to our model. Well, not really, they get moved somewhere else, like loading from disk or whatever medium you have in the future, SSDs or SDDs or whatever, I don't know what they are. It's all beyond me. I'm a programmer. Well, I am a techie as well, but not that much these days. So there you go. That's your test data. Pop that in. I'll use asterisks because I can. There we are. Lovely. So you got some test examples now of how to use it. So that's how you use your model. You use your camera in exactly the same way, but in reverse. Because, yeah, that's the way it goes, folks. All you got to do is remember that minus is into the screen until you turn your camera around and you have a brainstorm and realize you can turn your camera around by 180 degrees at the start. And then everything becomes positive. Wow, yeah. Why didn't we do that? Because I had to show you the correct way first. Yeah. And that's roughly all I've got to say on MVP, because it is just 3 black boxes of jiggly numbers, which you can control using translate, rotate. There's dot scale as well. And there's all these other things that you can do. Yeah, set rows and columns and set to identity I've just talked about a little bit. There's orthographical rather than perspective, which is a different type of perspective, orthographic. That's a flat one. So as things go into the distance, they don't change size. Very good for making 2D scrollers games. Fantastic for that. Or top-down games, which I don't mess about with too much. You can remap it to points on the screen. Yeah. What the heck's it? Oh, there you go. So it uses a double here. Determinant. Returns the determinant of this matrix. There you go. That means a lot to you, and it means just as much to me. Copy data to, yeah, okay. Tells you how you can make them. That's fine. So you can make them with another matrix or a transform or a generic matrix. Oh god, yeah. So the main parts to it is scale, translate, and rotate. That's the 3 biggies. And that's it. And that's how you use little black boxes full of jiggly numbers. Lovely. I think that's fantastic. I think that's so easy to do. It's, well, a little bit ridiculous. And that's standard Qt. That's what you get out of the box. I haven't written anything special there. All I've done is use their Q 4x4 matrix, and it does it. Yeah. Obviously, you wouldn't do it here. You would probably have those two there, and all of the test stuff would be in the class for your object, entity, or camera. Yeah, it's pretty obvious what you do. And all of this can get lost. I mean, really, what you want here is load model. Yeah. And then you just put in here model view, model projection, model view. Well, projection you would always come from outside here. Always take your projection from your screen. Sorted. That comes from the camera. Yeah, it's all obvious stuff. So you can now do exploration further into this, and you can. I've given you the basics of how Qt uses OpenGL very happily to load in some very simple data. I want complex data. I want full models. I don't want this. And I think that goes beyond exploration. I think that's a separate series. So I will be doing that next, actually. I think we're going to end this series here, take a break on it, and go and do a new series where we learn properly how to load up objects from disk and dispel a lot of the misconceptions that surround that. There's a lot of talky bits in that one because there's a lot of things I've learnt over the years that are just complete and utter rubbish. And I mean complete and utter rubbish. My mind is now filled with rubbish, and I don't want to pass that on to you. I want to pass on to you the truth behind the big secret of how to load an object off a disk or whatever medium you want to use. It's easy. It's very, very easy if you look at it in the right way. Okay, anything else I want to do with that? Oh yeah, you know how to put more buttons on, don't you? So that should be easy enough. You just go to your forms in here, and you just drop another button on. Like, get a button, make sure it's inside this one here, make sure it's probably at the bottom so you can see it trying to highlight here. There it is, it's highlighted now, it's just there. And you just do that. Rename it to button underscore test 3, rename it, double clicking it, you know, I'll show you test 3. There you go, return. There you go, there's your new button. You can check it out. Just press play here and it'll sort it all out for you. There you go, there's your test 3. Doesn't do anything yet because I haven't programmed it. There you go, test 2's working, test 1's working, test 2's working still. Yes, it didn't reset. So it'll disappear. And that's roughly about it. So you can add buttons, quite a few actually, and you can explore. I will be using test 3, so I'll leave it on. I'll show you how it all gets put together. What's this here? Oh, right here. Applications popped up. Thank you. Here I'll call this button underscore test 3. And then on the button, I'm just going to right click, go to slot, clicked. OK. And put in here what I always put in here, which is, I'll just take one of these, I don't know. Copy test 1. Oh, it's test 0, is it? Test 1, test 2. Yeah, okay, just pop in here. Test 3. Yeah, I know, it's silly, isn't it? Really. UI main view, set test 3. So that's set. You go around to your UI here and draw test 2. No, that's the wrong thing. Exploration, CPP, and down here you just say else if m_test is equal to 3, then you just want to run test 3, which we haven't got. There may be an initialization for test 3 here, and you might want to either put it in there or wherever I put it. Where did I put the oh, sorry, wrong one. Yeah, test 2, yeah, hash include test 3, but you have to make your test 3 first, which is a good idea. Your tests should always follow this kind of format, maybe not, with it's up to you how you want to structure this, but I always start with initialize and a draw, at least. There may be other things like update as well go in there. It's up to you. Exploration doesn't have an update function, does it? No, it doesn't, which is fine. I don't think I want one in here, because it's updating through here anyway. But you can keep this going for as many tests as you want. You can keep your tests as short or as long as you want. What I would also advise is thinking about how to store the information that we have now in test 2. Oops, save please. So in test 2, how are we going to start storing this information and using it in English, like saying please load me a model? But see me next series. It's what are we going to call it? How about C++ Qt loading 3D models, and I'll put in brackets .obj for the style of models. Yeah, so I'm going to do a series on that. I might come back to this series after doing it. I'll be doing it as test 3. I'll be using this structure in that series because I'd be an idiot not to. It's too good. It's a good workbench. It has everything there, and it's got all my notes now for how Qt works. So I can use these notes, and I do need to use these notes because I need to know how to do the data and how to set the data up for reading a file into data structures. That's that. I am quite happy with the result, absolutely. Result is very, very good, I think. So I hope you've enjoyed this so far, and if you want other things, other tests doing, I know that I want to do particle effects. What else do I want to do? I might try and do a fire. I might do liquids. Stuff like that. Special effects. I mean, you could have a whole test devoted to special effects. It's obvious what you could try and do, but that's the whole point. That's the whole point of this workbench. So I'll catch you in the next episode or the next series. Take care, and of course, explore. Have fun.